Review, and then we've got more reviews. Welcome back, everybody. Welcome to Fabulous Finance Friday. It is fabulous because all of y'all are here this morning. Thank you for coming out early on a Friday to review because, as you have been told, I am sure, the ETS test that you're taking is pretty important. Isn't it part of your grade in your final class strategy? Okay. Plus, it is something that you want to look at for going forward in the future because our scores are compared with scores from other students from other colleges and universities. And we know that you're a smart and educated group of people. But on these standardized tests, we want to do well on them so that everybody around the globe will know that you are a smart and educated group of people. Hoorah!
Hoorah!
Hoorah. Okay. We've got a brand new joke for you, one that I just wrote after each of you finished finance class. Are y'all ready? So there I was. Went to the grocery store and picked up in addition to the food, got y'all seen those apartment and houses for sale magazines? I got one of those to look at and a car magazine to look at that they give out. And then in Chattanooga, there is a newspaper, a weekly newspaper that is published in Spanish that if you're trying to learn the language, you can take this and you can translate and read the articles to develop some kind of proficiency for understanding. Well, I was translating back and forth trying to understand the article, and I came across a word that I did not recognize, the word lobo, L-O-B-O, and I'd not seen it before. And I turned to my dog and I asked, "Dog, what does the word lobo in Spanish mean?" And the dog looked at me and said, "Wolf." I mean, it actually means wolf, W-O-L-F. Oh, that was terrible. Nobody's going to actually do this tape later. I mean, I'm hoping that they'll just put it in the archives like at the end of the movie Raiders of the Lost Ark, where there's just this massive warehouse that had the Ark of the Covenant sitting there and nobody ever came and opened it. Anyways, does everybody have a copy of our little review sheet? We've got good news and we've got better news. The good news is that we will be talking about this morning what we talked about before in finance class, the time value of money. Now, some of these terms you should recognize, like the lump sum being a one-time payment. Say that you win $1,000 on that scratch-off lottery ticket, and you go and you deposit it into the bank. That's a lump sum one-time payment, contrasted with an annuity, which is a series of equal payments, where is anybody finishing up and graduating this semester? Wow. All of you are. Fantastic. And is anybody going to be looking for some kind of employment once you cross across that stage and everything? Okay. Now, here you are, a group of young whippersnappers, and you think that you're 10 feet tall and bulletproof, and you are, but what do you hope to be one of these days instead of a young person? An old retired person. Now, when you retire, you might quit going to the shop and earning that paycheck every week, and you'll have to live off any kind of savings that you've got. So who should it be that you should trust to take care of the old person you hope to be one day? The young person you are today. So instead of putting away money for retirement one time, you might want to consider putting a little bit back every single paycheck, okay? And doing so creates an annuity, a series of equal payments where you are engaging in the same activity over and over and over again. And we look at, in finance, the future value and the present value. If you recall, future value, we deposit money today, or we deposit money over and over and over again, and we ask the question, what amount does it grow to be in the future? Or if you're looking at some kind of future amount that you know you want to have $1 million when you turn 65 years old, that's your future value. What you want to know is, what is that equal to today? Or if it's a lump sum, or if you win the lottery and you're getting $50,000 a year for the next 20 years, but now, would anybody turn down an additional 50 grand a year for the next 20 years? Nobody? Okay. But when would you honestly rather have your money? Now. So you don't go to the lottery office and say, dude, man, I just won $1 million in the lottery, 50 a year for 20 years, but go ahead and give me $1 million right now today. And they will say, no, we'll give you, and we'll have to actually work a problem. But they might say, we'll give you $425,000 today. And you say, wait a minute, you're trying to rip me off because I won $1 million. They say, no, you didn't. Well, in a way you did, but you won that $1 million, 50 grand a year for 20 years, and that $50,000 20 years down the road is worth a whole lot less than $50,000 today. So when we calculate the present value, we discover that the present value is going to be less than that future value, okay? So y'all remember those things. And I believe in class we went over the fact that future values and present values can be calculated for both lump sums and for annuities. What we did, do y'all remember we had the magic tables and we used some formulas and we harvested numbers out of the word problems and plugged them into the formulas and got the magic number out of the table and tapped it in on our adding machine and got that right answer, and we all did the happy dance on test day and all of that good stuff? Well, we, I believe, mentioned that we can use the tables and formulas like we did. You can also use an Excel spreadsheet to calculate future value, present value of lump sums and annuities. You can do so with either the formulas, or you could spell it out step by step by step by step. You could get a hold of a financial calculator, either a freestanding financial calculator or at the, see, I had my new phone when y'all came through, didn't I? Did anybody remember the Motorola i205 that I had that was like a brick from 2003? Okay. It was the most amazing phone. It was like heavy as a brick. It was old, but I carried it for about 10 years. Now, you can go, if you got a smartphone or an iPhone or something, go to the application store and you can get this program to have a financial calculator on it for about $5 or so, which is a whole lot cheaper than going to Office Depot and buying a financial calculator when you can just carry it around on your telephone. Now, here's the better news. We've got the formulas and tables, we've got the Excel spreadsheet, we've got the financial calculator. The great news is on your test, we don't get to use our formulas and tables. We don't get to use a calculator. We don't get to use an Excel spreadsheet. What we've got to do is go very, very old school and do this calculation by hand. And that's what we've got on your handout today. 4 magic formulas that we would need to memorize. And these 4 magic formulas, the great news is 1 and 2 are easy variations of each other. If you memorize 1, then you can do a little algebra, solve it for 2. 3 and 4 are more complicated. And these, depending on the numbers you get, we will get to do some math and more math, okay? I'm sorry that the test is set up that way. There's more than one way to pet a cat, I believe we've learned, and the people that made the test are doing it differently than what we choose to do it, okay? But anyways, something you do need to remember is the order of operations. Do y'all remember that? What is it? Parentheses, exponents, multiply and divide, then add and subtract in that particular order, although the multiply and divide, we do those simultaneously. The add and subtract, we do those simultaneously as we're going through the problem. And our first type of problem says our future value is equal to our present value multiplied by the number 1 plus the interest rate raised to the power of t. And t represents the time frame between today and when we are having the final answer for the problem. This is not too hard to memorize, okay? The future value is present value, 1 plus I raised to the t. Now, depending on the number of time periods, your calculation on ETS day could take a little bit of time to do. Because what we do is, over on the second page, we've got a problem at the very, very, very bottom of the first page. Suppose you invest $1,000 into an account that pays 10% per year. How much is it worth in 5 years? Well, before we go even further with that problem, it says you invest $1,000. It does not say you invest $1,000 per year, does it? So if it says you invest $1,000 one time, is that a lump sum or an annuity? Perfect. And if we invest it today and it's asking how much is it worth in 5 years, are we solving for the present value or the future value? Future value. So you know, just by looking at the problem, it is a future value of a lump sum problem, and you've got this formula memorized, and you start harvesting numbers out of the problem to plug them in here, where you would say future value that I'm looking for is equal to the present value, the $1,000 that you are investing, multiplied by the number 1 plus the interest rate was 10%. And that's going to be raised to, how many years was it between now and when? Okay, fine. Okay. Now, something to be careful of. You are a smart group of people. Please, oh please, do converting your decimals, okay? Going from a percent to a decimal. 10% is equal to, what is a decimal? Good. 0.1 or 0.10. What if they give you 6% on the test? What is that equal to?
0.06.
Thank you. Good. 0.06. Please don't get in a hurry and write down 0.6. That will throw everything off quite a bit, okay? So here we are. We've got this. We've harvested our numbers. If we convert that to 1 plus 0.1, that comes out to be 1.1 raised to the power of 5 multiplied by 1,000 is equal to the future value. Okay? Now here's where it gets tedious. We get to take 1.1, let's see, we did the parentheses first, right? Now we do exponents. And when you've got 1.1 raised to the power of 5, you get to multiply 1.1 times 1.1. That gives you like 1, 1, 1, 1, 2, 1, 1.21. Does that sound right? That is right? That's right. And then you do 1.21 times 1.1 gives you 121, 121, 1331, 1.331, 1.331. And we got to keep count. How many times have we used this? 1, 2, 3. This is the fourth one. Gives you 1, 2, 3, 4, 1, 2, 3, 4, 1.4641. And one more time gives you what is that? 1, a 5. That gives you a 10, and a 10, 11. 2, 4, 6. Is that 1.6105 or 1, 2, 3, 4, 5? 1, 2, 3, 4, 5. 1.61051. Is that right? And before I published these, I pulled up our magic tables that we used when we were in finance class, and the numbers did match, okay? So to a certain number of decimal points, what you had on your table and what we've got right here, right now, doing this by hand, they came up the same. Now, I think this one I actually took a couple of decimal places more than your table said, so that the table would give you, when we finish this, if we'd done it by the table, you would have had 1.61051. I think the table cut off 1.611, so you'd be like 49 cents off on your final answer. But didn't we say in finance that close, for our purposes, worked because there's going to be some variations because of rounding? So on exam day, did they say that the test, you have multiple choice A, B, C, D, is that correct? Okay, good. So you would probably come up with an answer that's either spot on what they've got or a couple of pennies off, okay? So if it's a couple of pennies off, that would be the one to choose because of some kind of rounding situation. But when we multiply the 1,000 by the 1.61051, that should give us a final answer of $1,610.51, okay? If your answers on the test are 2,000, 3,000, 1,000, and $1,611, which one do you choose? Perfect. Okay. So the great news is you can do this. The not as great news is that this process could be kind of tedious. It is arithmetic, so y'all have done that many, many years before. It's just that you probably don't like going step by step by step, doing something that time consuming. Okay? Do we have any questions on this first one? So the moral of the story is, please memorize that formula and be prepared to be patient doing these calculations, one right after the other, in your order of operations, parentheses, exponents, multiply and divide, add and subtract, and you will want to make sure that you harvest the right numbers to go in the right places, and be careful with your decimal points, okay? You don't want a complicated problem to go astray just because we put 0.6 instead of 0.06. Who hates it when that happens to you? Who hates it when you're trying to run from the police that's parked behind you at the red light, and you've got a manual transmission, and instead of putting it in first, you put it in reverse, and you back into the squad car? That's not good, okay? So messing up a decimal point, or putting the wrong thing in the wrong place, or getting impatient and not being accurate with your calculations, that's not good either. Hoorah?
Hoorah.
Hoorah. Okay. Let's make sure. Okay, so then we've got the, what is it, present value of a lump sum. The formula for this one is present value is equal to future value divided by 1 plus I raised to the power of t. You can memorize this formula right there. Or you can do a little algebra on exam day where you just take that formula, the first one, you do want to memorize it. Solving for present value, it's being multiplied by that term right there. So you divide both sides by 1 plus I raised to the power of t to give you present value is equal to future value, 1 plus I raised to the power of t. So just an algebraic manipulation, not bad. I mean, you are the mighty graduate warriors of Dalton State. No longer just the mighty finance warriors, but the mighty graduates. So you can handle this, okay? Now, if we do this, we won't go through the multiplication of the 1.1 times itself 5 times, but we plug in the numbers. Our present value problem says we have 1,000, 5 years from now, discount rate 10% per year, how much is it worth today? So you plug in when it's asking how much is it worth today, we're solving for the present value, and that's equal to 1,000, the future value, over your 1 plus the interest rate of 10%, which would be 1.1, raised to the power of 5. And since we've already done it over there, that's what, 1.61051? You would have 1,000 divided by 1.61051. And then we get to do this business of, how do we even do that? Is that 1,000 right there? 1.61051. And you put the decimal and tack on some extra zeros, and you go through this division stuff that you did back in arithmetic class, which works out to be, what is that? Let's see. Oh. Do y'all remember what we have to do with the zero things? The decimal things? Well, we've got to 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So now you've got 161,051 divided into 1 and all of these zeros. And when we reach the point, let's see, there's 6 of them there, so it won't go into the first 6, but it might go in there. So we go through this process of the arithmetic. We've only got 14 minutes left. Do y'all want to do some arithmetic, or want to take a look at the next couple? Next couple, okay. So y'all do this arithmetic, and your answer should come out to be $620.92, or something really, really close. Okay? So the present value and the future value of a lump sum, formulas are the same, straightforward. The headache is the arithmetic. Okay? Now, the future value of the annuity. This is going to have a formula that is more involved, but it's the same in that you just take your time, do the arithmetic in the order of operations, and you'll be fine. Okay? Formula's going to look like the future value of an annuity is equal to, okay, you've got 1 plus your interest rate raised to the power of t. You know, that's becoming a theme, isn't it? 1 plus the interest rate raised to the power of t. Now, you take that and you subtract off 1. You subtract off 1 from this, and then you divide this number by the interest rate. And then once you do all of that, you multiply it by your payment. And that should give us our number that we're looking for. So, and with using the same numbers, only now we are putting in $1,000 per year. That per year is a signal that tells you annuity, right? And it's asking how much is it worth in 5 years. So we're looking for the future value of the annuity. So we go through, harvest our numbers, and we've got 1 plus 0.1 raised to the power of 5 minus 1 divided by the interest rate, and all of that multiplied by the payment. So that 1 plus 0.1 is what? 1.1 raised to the power of 5 was the 1.6 61051 minus 1. All of that divided by the interest rate. All of that multiplied, and the interest rate was what, 10% or 0.1, multiplied by the payment of $1,000. 1.61 minus 1 gives you 0.61. When you divide that by 0.1, the great news is this time it should be pretty straightforward. We just move that decimal, move that one, and it gives you 6.1051 times $1,000, which is $6,105.10. So the most challenging part on this is going to be memorizing that formula right there. But you guys have made it this far. You've done more difficult and more challenging things than this. So I've got faith that you can do this also. Right? What do you say, Mr. Hand? I say right. Okay, good. Are they actually going to watch this video in the library? Okay, good. I can just see the academic dean calling me and we'd like to talk to you about this review that you held. Now, one last step on this problem. Please check it for reasonableness. Okay? How much of your money did you put into the investment? $1,000 per year for 5 years. 5 years. So how much total? $5,000. Good. So we're going to go under the assumption that we will have at least $5,000 in the account. Okay? We come up with an answer of $6,105. Is that more than $5,000? Yes. Does it look like a reasonable amount when we consider the growth? If we had come up with, well, we put $1,000 a year in for 5 years, and we wound up with $61,000. Does that make you stop and scratch your head just a little bit and say, wait a minute, that's a big growth for that short of a time frame? Put in $5,000, got 61 grand. Something just doesn't seem right, does it? So you say, okay, let me go back to the drawing board, and you find, oh wait, I missed a decimal point one place. So you come up with 6,105. That seems reasonable, and we're good. Make sense? So in all of your word problems, please check your final answer to make sure it is reasonable. Okay? Do y'all have any questions on the future value of the annuity? Then, if you're okay with the future value of the annuity, present value of the annuity should be very similar. Only big difference is, for the future value, you are, well, it is a little bit with the
Exponent.
yeah, that exponent right there. And what we're gonna do is have a formula that says present value of the annuity is equal to 1 minus 1 plus I, only this 1 plus I is raised to the negative t. Then we divide by I and multiply all of this by the payment. We've got a negative exponent. What do we need to do whenever we have a negative exponent? We do the inverse, right? Create a fraction out of it. So we've got 1 minus 1 over 1 plus 0.10 to the 5th power. Say, wait a minute, Fat Daddy, that was a negative. You're right. But it becomes a positive when we put 1 over that, right? So we're doing this inversion. Then we've got the division of all of this by I, or 0.10. And then we multiply whatever we get right there by the payment of $1,000. So what we're looking at doing is 1 plus 0.10, we do the parentheses first. That gives you the 1.1 right there. Then when we raise 1.1 to the 5th power, it would be great on the ETS if they use the same numbers for each and every problem. I have a funny, sick feeling that they're going to use different numbers for each type of problem. I mean, as sick of a feeling as I had that time at Chef Lynn, when I thought I was getting a vegetable egg roll. Do you know what's worse for my kind? Is there anybody else who does not eat seafood? Who just doesn't do seafood? Thank you. You know what's worse than finding a shrimp in your egg roll? Finding the other half of a shrimp in your egg roll. And that's what I found. And I turned the prettiest shade of green. I am that green right now, thinking that they're going to use different numbers for each problem on your test. So we've got it good in our examples because we know that 1.1 raised to the 5th is that 1.61, but you might get to do this kind of multiplication for each one of them, okay? But you're strong, you're tough, you can do it, right? Yes. So now you've got 1 minus 1 over the 1.61, which is, when you do that, that fraction comes out to 0.6209 at the bottom of page 3. When you subtract it from 1, that gives you 0.3791. Then you divide that by the interest rate of 0.10, which is 3.791. Multiply that by the $1,000, and we come up with the present value of this annuity is $3,791. Now, when you're looking at that again, go back and test to see if it is reasonable. How much money were we receiving per year? $1,000 over how many years? 5. So we would get $5,000 over that period of time. Now, we remember that a present value of an annuity is going to have an answer that is less than the total amount of cash flows we receive. So is $3,791, is that less than $5,000? Yes. So that part of it looks good. Now, is it amazingly less? Like, well, you can have $1,000 for 5 years, or we'll give you $37.91 today. That would be a pretty drastic drop. Does 1,000 a year, 5,000 over 5 years versus $37.91 today, does that seem reasonable according to what we've done in class? It does. So that is a good sign. So to wrap it up before Dr. Jones arrives very briefly, please, oh please, you've got the magic formulas in front of you. It'd be great to memorize all 4 of them. If you have to choose, you say, dude, man, I can only memorize 3, then memorize number 1, 3, and 4, because number 2 is easy to derive algebraically just by moving the one term to the other side. The 1 plus I raised to the power of t, dividing both sides of it on the future value will give you the present value for it. Remember, order of operations. Take your time, go painfully slowly when you are doing your calculations, and check your final answer for reasonableness. Do y'all have any questions before I hand it over? Are your hearts clear? Has everybody got a copy of this? Okay. Were you going to take attendance, or shall I pass around?
No, absolutely not.
Okay.
Neil, you want to turn that puppy on for me?